Hi, Mr. Richards here. Today's lesson is on multiplying and dividing rational expressions. And like multiplying fractions of any type, you multiply the numerator by the numerator and the denominator by the denominator. And also similar to fractions, if you can cross simplify, then it makes it easier when you multiply. Well, the same holds true here. You could multiply 7x squared y times 14z straight across and get something like 98x squared yz. You could multiply the denominators and get something like 588xy to the fourth z to the third and simplify that. Or you could divide by the common factors before multiplying, and that's what we'll try here. So if we rewrite this, kind of spacing it out a bit, we would have 7 times x squared times y over 12 times z to the third, and that's going to be multiplied by 14 times z over 49 times x multiplied by y to the fourth. If we first look at this 7 here, anything on the bottom we can simplify that with? Well, yeah, the 49. So if we divide the 7 by 7 and the 49 by 7, we're left with 1 and 7. What about the x squared? Well, we have an x down here, so we could divide this x squared by x and this x by x and left with x and 1. What about the y? Well, we could divide this y and this y by y, and we'd be left with 1 and y to the third. What about the 14? Well, this 14 we could divide by 7 and get 2, and divide this 7 by 7 and get 1, top and bottom. What about the z? We can divide this z and this z by z, and we're left with 1 and z squared. And on the top seems to be about as simplified as we can, except we have one more little step we could take, where we could divide this 12 and this 2 both by 2. We'd be left with 6 and 1. And so now, when it's all said and done, and we multiply all the things together again, 1 times x times 1 times 1 times 1 is just, well, x over 6 times z squared times 1 times 1 times y to the third would be 6 y to the third z squared. And that's our final product. Next we have find the product of b plus 3 over 4b minus 12 multiplied by b squared minus 4b plus 3 over b squared minus 7b minus 30. Well, what I would do first here is to factor anything we can. So we're going to be left with here, b plus 3 does not factor. However, on the bottom, if we factor out a 4 from the 4b minus 12, we'd be left with 4 times b minus 3, and that would multiply by b squared minus 4b plus 3. Well, if we just make a little note here, what multiplies to be 3 with the sum of negative 4, how about negative 3 and negative 1? Well, that would factor then into b minus 3 times b minus 1. In the bottom, b squared minus 7b minus 30, we can look to factor that, and is there anything that is a product of negative 30? that adds up to be a sum of -7? Well, what about -10 times +3? That's -7. And so we can factor this into b minus 10 times b plus 3. And now we can look to simplify. We would have this b plus 3 here can simplify with this b plus 3. Those both become 1s. We have this b minus 3 and this b minus 3 that can both become 1s as well. So what we're left with now, b minus 1 over 4 times b minus 10. And to finish, we do want to multiply on the bottom there. So b minus 1 times 4b minus 40, that is our simplified product. So we factored, we divided out the common factors, and then multiplied to finish our product. Now, you might remember from earlier in the year that dimensional analysis is the process of carrying units throughout a computation. You can use dimensional analysis to convert units of measure within a system and between systems. Now, the velocity that a spacecraft must have in order to escape the Earth's gravitational pull is called the escape velocity. The escape velocity for a spacecraft leaving Earth is about 40,320 kilometers per hour. What is this speed in meters per second? Well, we can start off this problem now by writing out 40,320, and we'll abbreviate kilometers as km, and we'll write that as a fraction 1 hour. Now, our goal here is to get this to be in meters per second. And so if we work with our time unit first here, we need to get our hours into seconds. And so first, let's take our hours to minutes. And then we'll take our minutes to seconds. Well, I know for 1 hour, there's 60 minutes. And so we're going to write 1 hour on top over 60 minutes on the bottom, so that eventually this hour will be able to cancel out or simplify out. Then, for our minutes into seconds, I know 1 minute is 60 seconds, and again I want the minutes here to cancel out. And so I could write this now as 1 minute on top over 60 seconds on the bottom, so that once again these minutes will eventually simplify out. And now lastly, I need to get my kilometers into meters. Well, for 1 kilometer, there are 1,000 meters. So I can set this part of the question up by saying, all right, the 1 kilometer is going to go on the bottom so that the top is going to cancel with the bottom, and the 1,000 meters will go on top. And now if you look carefully, we're trying to get to meters per second, and here's our meters, and here's our seconds. And you can also then notice our hour unit cancels with the hour unit, 1 on top, 1 on bottom. This minute cancels with that minute, top and bottom. And then the kilometer cancels here with the kilometer. So all we're left with unit-wise are our meters and our seconds. And now we just multiply through. The 40,320 times 1,000 turns out to be 40 40,320,000 meters over 60 times 60 is 3,600 seconds. And now we do want to simplify this, so if we divide the 40,320,000 by 3,600, our simplified answer is 11,200 meters per second. And that is the escape velocity for leaving Earth, 11,200 meters per second. Remember back when you first learned how to divide fractions? There was the whole multiplying by the reciprocal thing, keep, change, flip. Well, we're going to do the same thing here as we divide rational expressions. We're going to multiply by the reciprocal. So 8 over 20x cubed divided by 44 over 25x squared is going to become, keep, 8 over 20x cubed, change the division into multiplication, and the reciprocal here is 25x squared over 44. And if I rewrite this out a little bit, just to give myself some more room, 8 over 20 times x cubed times 25 times x squared over 44. Again, just rewriting it to give myself more room so I can cancel and not get too lost here. If I divide both this 8 and 44 by 4, this 8 is 2, and 44 divided by 4 is 11. What about the 20 and 25? Well, if I divide both those by 5, 20 divided by 5 is 4, and 25 divided by 5 is 5. What about the x's? Well, if I divide the x cubed and the x squared by x squared, I'm left with 1 and x. And there is one more thing we can simplify, this 2 and the 4. If I divide both those by 2, I am left with 1 and 2. And so now when I go to piece this back together, 1 times 5 times 1 is just 5. 2 times x times 11 is 22x. And so my simplified quotient after I multiply by the reciprocal is 5 over 22x. Now we have to find the quotient 3x plus 9 over x squared divided by x plus 3. Well, let's rewrite this binomial here, x plus 3, as a fraction. So we'll keep the 3x plus 9 over x squared divided by still. We can put this x plus 3 over 1. Now if we multiply by the reciprocal, we're left with 3x plus 9 still. We keep the first term, change the division into multiplication, and the reciprocal is 1 over x plus 3. Next, if we look to factor out this 3x plus 9, we'd be left with 3 times x plus 3 over x squared times 1 over x plus 3. And something cool kind of happens here. I can cancel out this x plus 3, as that's a common factor here, and that just simply, well, simplifies. And so what do I have now? 3 times 1 is 3 over x squared times, well, those were both just 1s, is just x squared. And that's the final simplified answer, 3 over x squared. Now for this question, y minus 6 over 2y plus 6 divided by y plus 2 over y plus 3. Let's go ahead right away and multiply by the reciprocal. So y minus 6 over 2y plus 6 multiplied by y plus 3. over y plus 2. Next, if we look at the 2y plus 6 and try to factor that out, we'll have y minus 6, and if we factor out a 2, this would be 2 times y plus 3 times y plus 3 over y plus 2. So if we simplify this by dividing out the y plus 3 and those become 1, we're left with y minus 6 over 2 times 1 over y plus 2. Well, now I can just multiply this through. Y minus 6 times 1 is just y minus 6 over 2 times y plus 2, if we distribute here, is 2y plus 4. And that is the most I can simplify here. We're left with y minus 6 over 2y plus 4. In our last example of this lesson, we have expressions involving polynomials, and my hint is you are going to need to factor, so find the quotient x minus 5 over x squared minus 9x plus 18 divided by x squared minus 25 over x minus 6. Let's go ahead and rewrite this by multiplying by the reciprocal, so keep the x minus 5 over x squared minus 9x plus 18. This shifts to multiplication or changes, and the reciprocal is x minus 6 over x squared minus 25. And as we look to factor the x squared minus 9x plus 18, we can look for a product of 18 that has a sum of negative 9. Well, we need a negative times a negative, so negative 3 times negative 6 is positive 18 with a sum of negative 9. So we can rewrite this first portion as x minus 5 over x minus 3 times x minus 6. Next, if we look to factor the x squared minus 25, we can use our difference of squares rules. If we remember that, it states that when I have something like a squared minus b squared, I can factor this into just a plus b times a minus b. And that's what I have here. So I could keep the x minus 6 over square root of x squared is x, square root of 25 is 5, so x plus 5 times x minus 5. And if you need to go back to chapter 8 for differences of squares, that's how that was just factored. So now we can simplify some of these GCFs here. We have this x minus 5 that simplifies with this x minus 5, and those both become 1. We have this x minus 6 and this x minus 6, and those are both 1. So now we can multiply these through. 1 times 1 is 1 over x minus 3 times x plus 5. And that is our simplified answer, 1 over x minus 3 times x plus 5. And that is it for this lesson on multiplying and dividing rational expressions. Good luck.